This is Ndefo Okigbo classes. We are starting lectures on motion. We have dealt with structures that are in equilibrium, that is static equilibrium. We're now going to deal with dynamic equilibrium. In the static equilibrium, we dealt with structures that are determinate. Now we have to think of structures that are in motion. We're going to talk about motion this time. And the motion studies, we handle motions two ways. We handle motions as motion studies as kinematics or as kinematics or dynamics or dynamics. Motion is always generated, that's movement is always generated by force. It's generated by force. In short, force generates motion. Force maintains motion. Force changes direction of motion. Force also stops motion. So everything about motion is caused by force. But sometimes we tend to study the motion not considering the force that is causing the motion. And when we study motion without considering the force that causes the motion, we are dealing with what we call kinematics. But when the force causing the motion is considered, we talk about dynamics, studying motion, considering the forces that are causing the motion. That is dynamics. Studying motion without considering the forces that cause the motion. Kinematics. So now, in movement, when in the motion we are talking about could be in a straight line, it could be in a curve. When it is in a straight line, we say it is rectilinear motion. Rectilinear motion. While the other, in a curve, is called curvilinear motion. Curvilinear motion. So when a vehicle, whatever, a body is in motion, it tends to, change the coverage, because if it means it's covering space when it's moving. It's covering space. And if this covering of space is done in a straight line, in a particular direction, in one direction, it is said to be displacement. But if it is covered in different directions, that is what is covering is called distance. So distance is displacement displacement is distance in a particular direction. That's why displacement is a vector. A vector is a quantity that has magnitude and the specific direction. Not that it doesn't have direction, but direction is specific. While a scalar has quantity and it doesn't have a specific direction. That is, it could be in different directions. So displacement, which is covered when a body is moving in a straight line in one particular direction, is a vector. While this distance, which is also space covered in motion, in different directions, not specific direction, that is scalar. So as the movement is going on, now we check how far has the movement gone in a particular time. When we check how far the movement has gone in a particular time, we start thinking of the rate of the movement, rate of change of distance or rate of change of displacement. When we talk of rate of change of displacement, we have velocity. Velocity is displacement over time. We're using S for displacement or distance. Velocity is distance. That speed is distance over time. Velocity is displacement over time. So if we check the rate at which space is covered, at rate at which distance is covered, the rate at which displacement is covered, we talk of either speed or velocity. Now, as the movement continues, if the body is moving at constant velocity, it will not accelerate. Acceleration becomes zero. So, and when it's moving, we talk of average velocity, because it is velocity, instantaneous velocity at given instant of time, to get an average velocity. We have an average velocity, space divided by time, because each space is space covered in given time, and time is the number of instants it occurred. So average velocity, just like velocity is displacement over time. While the velocity, the thing is moving at given velocity, it may increase its rate of movement. If it increases, that means there was a rate it was coming with, and it now changes to another rate. That is, there was a rate which we call initial, and the next one is final. So if we have initial velocity, which we use u to represent, and final velocity we use v to represent. So acceleration, change in that rate of, change in rate of movement, change in rate of movement per unit time, acceleration. That means A, we represent acceleration with A, which is v minus u over time. That is the velocity, changing, that is changing velocity. Final velocity minus initial velocity over time. Changing velocity over time, that's acceleration of, and but if the movement is with the constant acceleration, that means there is this change will not occur. The constant, then velocity will be equal to, acceleration will be equal to 0 if the velocity is constant. Now, when the moving object wants to stop, instead of accelerating, it starts to reduce speed. It starts retarding. And that retardation is called negative acceleration. It's called negative acceleration or deceleration. That is, it's retarding. So here we have, if we have the acceleration is equal to v minus u over t, that is final velocity minus u, initial velocity over time. If we work this, we will have that at is equal to v minus u, which means that if we make v the subject, v becomes equal to u plus at. This is called the first equation of motion. This is called the first equation of motion. This is called the first equation of motion. But if we have that from here, we have that this displacement from the here, displacement is equal to average velocity. Is equal to average velocity times time, which the average velocity is equal to v plus u over 2 average, which means it is equal to v plus u over 2 times time. And we know from equation 1 that v is equal to this, v is equal to u plus at, which means replacing v, we have u plus at plus u all multiplied by t all over 2, which is equal to 2u, u plus u, 2u t plus at squared over 2, at squared over 2, which means that s is equal to this over 2, 2 cancel 2, ut plus half at squared. This is called second equation of motion. S is equal to ut plus half at squared. Second equation of motion. Second equation of motion. Second equation of motion. So from here we have that, we still remember that a acceleration is equal to, from here we have that acceleration is equal to acceleration A is equal to v minus u over t, v minus u over t, which means, and we know that s, from s is equal to this, s is equal to average velocity times time over 2. So if we now replace t here, if we replace t will be equal to, from here, 2s over v plus u. 2s over v plus u. That's t is equal to 2s over, from here. That's what this arrow means, from here. T, because s is equal to this. Then t is equal to 2s over v plus u if you make t the subject of the formula. So if you bring it here, that means a will be equal to v minus u. If you replace t with this, that will be bracket v plus u all over 2s, which implies that 2, if you send it up to meet a, 2as is equal to this times this is something as v squared minus u squared. You can work it out and see. V squared minus u squared. If you expand this times this, and then you will get v squared minus u squared. Which means if you make v squared the subject, it will be equal to u squared plus 2as. This is also the third equation of motion. V squared is equal to u squared plus 2as. So I have been able to get the three equations of motion. So I got them as 1. V is equal to u plus at, equation 1. S is equal to ut plus half at squared, equation 2. V squared is equal to u squared plus 2as, equation 3. We will use these three equations in solving most of the motion problems we are going to deal with now. We're going to use these three equations to deal with them, to solve them, and get our answer. I've been able to, apart from the explanation of motion, I've been able to explain and prove the three equations of motion. So the next thing will be our solving problems using the equations of motion. Thank you very much for the end of this episode.